All right, how's it going, everybody? This is the first lesson in our new notebook for spring semester. We're starting in chapter 5, functions in general. This lesson 5.1 is called Evaluating Functions. We are starting a new unit in Con. So FUN here stands for functions. And in Khan Academy, I believe that's unit 8. All right, and this covers skills 1 through 5 in Khan Academy, unit 8. Our objective is that you'll be able to identify functions from their graphs and tables, and we'll be able to evaluate functions from a graph and algebraically. Okay, so the big word here is functions. That's going to be our first definition. A function is a relation for which each input has exactly one output. Okay, so there's actually two words here that you should know. They might be newer to you, but a relation is more general. It's just going to be any kind of rule that maps inputs to outputs or maps x values and sends them to y values, but there's no restrictions on what that rule could be. A function is a specific type of relation, and again, it has to, for every input you give the function, that input has to have only one output. Okay, so this is a linear function. F of x equals mx plus b, and that should look really familiar to you. So you can write this down on the side here. Recall from last semester, a linear equation looks like this. Y equals mx plus b. We call that slope-intercept form, right? It's pretty much the same as this. We just switched the y with this f parentheses x, and that's read f of x. It does not mean multiplying, even though you've seen parentheses mean multiply before. This is a new notation. Pretty much what we're saying is that y, if it's a linear function, y is a function of x. Y equals f of x. And so we read that that's telling us that y is a function of x. So later on, you might have functions of different variables, but in this case, y is defined, y is based on the x value. And so let's go ahead and fill in this table here. The x values, we're still going to just call them x, but instead of the y values, we're going to call them f of x, or the function evaluated at x. And that x value is a variable. It can change. Speaking of variables, that's the next row we're going to fill in. The x values represent the independent variable. So they can be whatever you want them to be, but once you pick that x value, then you can use that function to determine what the y value will be, or what that f of x value will be. And because of that, our y values are dependent. They're the dependent variable. They depend on what x is. So thinking of functions as a rule that takes inputs and gives you outputs, the x values would be the inputs. You need to know what you're putting into the function in order to figure out what comes out. What's the output? Okay. A good example of a function. Functions don't always have to just relate numbers. It could be something like grades. I could have a function, let's just call this a function f, and you could put in a percentage. Let's say you get a 95% on a test. Well, that output would be an A. So these are our x values. These are our f of x values, or you could think of them as y values. But 95 isn't going to go anywhere else. It wouldn't be fair, right? I couldn't give, if you got a 95 and I give you an A, and then later on I map somebody else gets a 95 and I give them a B, that's not fair. That wouldn't be a function. But if somebody got, let's say, a 79, according to our grade book, that would be a C. Or if you want to put a plus, you could put a C plus. But once you set that x value, that input, it can only go to one output, and that's what makes it a function. Okay. So moving on, we're going to learn how to identify functions from a graph. So I'm not giving you numbers, I'm not giving you letters or anything. This is just our xy plane. So we have our x-axis here and our y-axis. And this first picture represents a function. And it's because of this dashed line here. This is a visual representation of what we call the vertical line test. So I'm going to uncover that now. Let's zoom in a little bit so you can copy this into your notes. The vertical line test is stated as follows. A graph represents a function if and only if every possible vertical line intersects the graph at most once. I know this definition is a little bit wordy, and you might not have seen this phrase if and only if before. I'll explain that. But basically, this if and only if means it goes both ways. A graph is a function if, let's just go ahead and erase that. A graph is a function if this is true, but it also works the other way. If you notice this stuff is true, then the graph is a function, or if you know the graph is a function, you can conclude that this stuff is true. This is a definition. Okay. Notice it says every possible vertical line intersects the graph at most once. So there's one vertical line here, and it does only cross that curve once. But I want you to visualize in your head any other vertical line you want. Vertical, up and down, right? So like maybe you were thinking of this vertical line. Notice it still only crosses the graph once. Or maybe this vertical line only crosses once. This vertical line only crosses once. Any vertical line you want crosses only once. In contrast, this would not be a function, and you don't need to visualize a bunch of different lines. As long as you find one line that breaks this rule, then you can say, okay, it's not a function. So here's one line, one vertical line, that crosses the graph twice, and that means it's not a function. And you can kind of tie this back to the vertical, the rule that each input has exactly one output. So because this is an x value, it's our input, but it maps to two different y values, two different outputs. There's the first y value, but that same x also goes to a different y value, so it's not a function. Same thing here. We've got another violation of the vertical line test. This is not a function either. I have one more picture for you. Is this a function? Go ahead and take a look at the picture, pause the video if you want, and then decide for yourself, is this a function or not, and be ready to explain why. All right, so this is actually not a function because there is a vertical line that could be drawn that crosses the function more than once. This red line here crosses twice. This is a little bit tricky because if you think of the wrong vertical line, let's say, I'll do it in purple here. Here's a vertical line that does only cross once. But if you look back at our definition of the vertical line test, every possible vertical line can only intersect once. So even though you have an example of one line that crosses once, here's a different example where that's not the case. And so we would say that no, this is not a function. All right, let's identify functions from a table now. Basically, we only want our x values to be listed once if you're given a table. So 0 is our input. It only maps to 0. It doesn't go anywhere else. 1 maps to 40. 2 maps to 40 also. That's allowed. You can have different inputs that map to the same output. But if I pick a specific input, like 3, it only goes to one output. In contrast, this table on the right is not a function because you have an input of 3 here that maps to 54 as an output. But that same input, 3, also goes to a different output, 84. So that's not a function. It should also be noted that all of these examples here, all of these are relations, but not all of them are functions. Okay, let's try a few examples. So on the next page, we've got example 1 here. It tells us that f of x is 2x plus 1. Okay, and again, you can think of this as a linear function or a linear equation. Y equals 2x plus 1 is how we would have written it last semester, but now we're writing it in function notation. So we're going to complete the table. Instead of a y column on the right, we'll call it the f of x column. And it's asking us, what is f of x when x is 1? And the way we write that is, we'll find out what f of 1 is. That means we're going to plug in a 1 everywhere we see an x. So our function was 2x plus 1. We're just going to plug in a 1. And we should be able to do that using mental math. What's 2 times 1 plus 1? Well, that's 2 times 1 is 2, plus 1 is 3. So our output is 3. Try it again. We have a different input this time. We're going to find out what f of 2 is. We're going to write the same function, but plug in a 2 in place of x. 2 times 2 plus 1, that's 4 plus 1, which should be 5. Let's try our last one here. If the input is 3, what's f of 3? That's going to be 2 times 3 plus 1. That's going to be 6 plus 1, which is 7. The last one's a little bit different because we're not trying to find an output. We are given an output and asked to find an input. So we're going to say that f of x, some input we don't know yet, equals 11. But we know what f of x is. It's 2x plus 1. So we can say 2x plus 1 equals 11. And you've solved many equations just like this last semester. So let's get x by itself. We need to undo what's happening to the variable. Let's subtract 1 from both sides. We'll end up with 2x equals 10. And if we divide both sides by 2, we'll get x is 5. So we know that the input we're looking for is 5 to get an output of 11. All right. I want you to try practice problem number 1 on your own. We have the function f of x equals 4x plus 11. Fill in the table and then come back and check your work. There we go. So, same idea. We're looking for f of x here. We have our 3 inputs. Plug those inputs in for x to get the output. And then the last row in the table is asking you to find an input given the output of 27. So if f of x is 27, that means 4x plus 11 is 27. So we'd end up with x equals 4. Okay, that's evaluating functions using a table. Here's how we would evaluate from a graph. Let's color code this one. So this first one is saying f of 4. So what is our output when x is 4? So we find 4 on our graph on the x-axis, and this would be the point that you should look at. That's the point on the graph with an x-coordinate of 4. It's asking what's the output, what's the y-coordinate or the f of x coordinate? It's 3. All right, I'm not going to keep drawing the arrows, but it's the same idea. So when x is 0, the point on the graph with an x-coordinate of 0 is right here in blue. The y-coordinate, or the output, or the f of x coordinate, is 1. We've got another input here. When x is negative 1, that's this point on the graph. The y-coordinate is also 1. When x is 2, there's our point. Our output is 2, right here. And one more input. when x is -3, the point on the graph with an x-coordinate of -3 is right there in purple. The y-coordinate of that point, or the output, is 0. And finally, I'll do this one in pink. We're asked to find an input this time. So our y-coordinate is -3. So where on the graph, which point on the graph has a y-coordinate of -3? We're starting right here, and that's the point we're looking for. The input that would be sent to -3 is the value x equals -4. There we go. Try practice problem number 2. It's just like this one. Pause the video, do the work, and then come back and check your answers. All right. There we go. So you're given various inputs, and you can find the outputs. I've color-coded them here. So there's that when x is -2, y is -4. When x is -6, y is -5, and so on. I do want to point out that for this last one, they give you an output. They're asking what input gets sent to 1, or what x value gets sent to a y value of 1. There's multiple, and that's okay. Our 1 is right here. Our output of 1, our y value, is right here. And notice that there's 2 pink dots there. That means that when x is about 1.5, y would be 1, but also when x is 7, y would be 1. All right. You might be asked to solve functions just given an equation. So this is solving it algebraically. If f of x is -x plus 5, find x when, oh, this should be an f here. Go ahead and fix that. That's a typo. When f of x is 2. Well, if f of x equals this stuff, and f of x also equals 2, you can set those equal to each other. -x plus 5 equals 2. Solve this equation for x, and then you're good to go. You take 5 from both sides. So -x equals -3. And then that would mean x is 3. All right. Try the remaining 3 on your own, and then come back and check your work. There we go. Go ahead and check your answers. As always, at the end of this video, please ask a question or make up your own question, and come to class ready for lesson 5.1.